Good evening. Welcome back to Chapter 3 with vectors, and we just got done doing a marathon session last night, 20 minutes long. I apologize for making that so long. We're going to make tonight's a lot shorter. But tonight, what we're going to talk about is adding vectors, but now this time we're going to do it analytically, because drawing them, as you learned in class today, was a little bit challenging, and it's not something you want to do all that often. So we want to find out a way to do it analytically. Before we get started, though, we need to define another term called equilibrance. Now, yesterday when we added vectors, I told you that the result of adding vectors, so if we had, here's vector A and here's vector B, and if we add those together by taking this and adding them head to tail as such, this gave us the resultant. Change colors. Oops, hang on, I need to go back to the regular color. There we go. This gave you a resultant of A plus B. And the resultant always goes from the tail of the first to the head of the last. So this is where you start, and this is where you end. That's for the resultant. Now the equilibrance is the negative of the resultant. And so your equilibrant is this. It's the exact same magnitude. It's just in the opposite direction. And basically, the equilibrant is the negative of the resultant. And I kind of term it as like, this is the vector that gets you back to where you started. Or this is the vector that balances out all of the other ones as well. And so when we did our Pythagorean Theorem one yesterday, we had vector A and vector B, the resultant was, hey, I went from here to here. That would allow me to go from, say, the straight line, from here's where I started to where I ended. The equilibrant gets us back to where we started. This is what our equilibrant is. And so we'll talk about this more, especially when we start talking about forces in Chapter 4. The equilibrium comes into play because then it's a vector that will equalize the other two. But I wanted you to be aware of what that terminology was. Okay, so in continuing on, adding vectors, if you add them graphically, and again, you saw this in class, adding them adding them graphically is tedious. You got to be very careful with how you measure. Make sure that they're the exact right length and drawing the scale. You have to make sure they're going in the exact right direction, because when you move it, it has to be in the same direction as what it was before. Otherwise, you get errors in there. So we have a different way of doing it, and in fact, using trigonometry. Okay? And this is all based off of the fact that it's a fundamental property of all vectors that any vector can be broken down into two perpendicular components. Now, in reality, a vector can be broken up into an infinite number of components, into an infinite number of pieces. But we're going to break it up into two because that's what helps us the best. And so what we're going to do is that we're going to take a vector and a vector acting at an angle, because really, if the vectors are parallel or equiparallel or even perpendicular to each other, those we already know how to add together. But what we're talking about is if we have a vector, like here's vector A. Now let's say the vector A is 3 steps in that direction. And now we have vector B, and vector B is not parallel. It is not equiparallel. It is not perpendicular. Let's make this 5 steps just for fun. 5 steps. And so your resultant, hang on, actually, I'm going to erase this right here. Your resultant, if you were to draw it graphically, would go from the tail of the first to the head of the last. This is the resultant. But we don't have a way to add these up, because again, you can't just add them because they're not parallel. You can't just subtract them because they're not equiparallel, and you just can't Pythagorate them together because they're not perpendicular. And so what we're going to do is we're going to take these vectors, this vector right here, and I'll highlight it, and we're going to break this apart into pieces. And we're going to do that by using trigonometry. And so what I'm going to do is I'm going to redraw my vector. Here's my 5 steps. And one of the things that will be given to you is that you'll be given an angle. And I'm going to tell you right now, just for our purposes, that this is going to be a 30-degree angle. They have to give you the angle because that tells you the direction of the vector. Yep. And so when I bring that down here, here's my 30 degrees. Again, not really, it should be the same, but obviously I screwed that up. Let me try that again. Let me reboot it. I know I'm kind of making this longer than it should be. 5 steps, 30 degrees. And what we're going to do is we're going to break this up into pieces by creating a right triangle, okay? And I'll talk about this in class, but basically what I'm going to do is I'm going to give you right triangle demigod powers. You are now going to have the ability to create or destroy right triangles on a whim. So use that power wisely. So what you're going to do is you're going to break this up into a piece. I'll put this in black and purple. But you're going to have a piece that goes horizontal. And this is going to be in the X direction. And then you're also going to have a piece, I'll put it purple, that goes vertical. And this is going to be a Y direction. And so what I'm going to do, since this is a right angle, I've created a right triangle, I can use my trigonometric functions, sine, cosine, and tangent, in order to find out what these are. Now, you'll find these in your reference tables, but for our purposes, remember, sine of an angle, sine of your angle, and theta is the symbol I use for my angle, is equal to the opposite over the hypotenuse. Cosine of your angle is equal to the adjacent over the hypotenuse. And then tangent of your angle is the opposite over the adjacent. And so what you're going to be given here, if you look at this, I have the hypotenuse, and I will label these. On this particular thing right here, I have my hypotenuse. My hypotenuse is 5. The X direction, that is my adjacent side. That is the side that's touching the angle that I know. And then my Y direction, that is my opposite side. And so by using my sine, cosine, and tangent, I can find out how big these sides are. And I'll do this really quickly. In my X direction, I'm going to do the cosine of 30 degrees is equal to the adjacent side over 5. And so my adjacent side is going to end up being 4.33. And I know that because I've done this a lot of times. In the Y direction, I'm going to use the sine. Sine of my 30 degrees is the opposite side over 5. And so my opposite side is going to be 2.5. And so what that allows me to do is to break up my 5 steps into 2 pieces. Now, when I break up that 5 steps, it is dead. Okay? And so what happens is, I'm going to redraw this. I have my 3 steps here that I had from before. I have my 5 steps. Did I do the color scheme right there? Nope, I should use red. My fault. Let me change that over real quick. I have my 5 steps, which I had in orange. And that's at an angle of 30 degrees. What I'm going to do here, and this is so you need to pay attention, what I am going to do here is I'm going to break that up. And so when I broke that up, I found that this side here was 4.33 steps. This side here was 2.5 steps. And when I when I broke up the 5 disappears. It gets destroyed. And so now this 5 is gone. The 30 is gone. That orange arrowhead is gone. And so I'm left with adding, instead of 2 vectors, I'm adding 3. which initially you might think is dumb. Why in the world would I do that? Here is my resultant. Until I look at this and say, hey, my 3 and my 4.33, those are parallel. I know how to add those. And so I'm going to put those two together, and I'll keep it in black, is going to be 7.33 steps. That whole thing is 7.33. Now this is perpendicular 2.5. I have Pythagorean Theorem to find out how big the green arrow is. And we'll practice this tomorrow. Okay? But it is this piece right here. This property allows us to add vectors. We break apart any vector that's acting in an angle into perpendicular pieces so that everything is either horizontal or vertical. We then add our parallels and antiparallels together to be left with two vectors remaining that are perpendicular to each other, the 7.33 and the 2.5. And then I can put that back together via Python. And so that's how I'm going to add them analytically. And so we're going to practice this a lot tomorrow. And so we're going to get good at this. If trigonometry is not your friend, I can help you with this. All you have to know is sine, cosine, tangent, and Pythagorean theorem, and you can do all of these. So we'll practice with this tomorrow. Everybody have a great night. We'll see you later. Bye.